Alright everyone, welcome back. We are starting 8.2 today and we will be using quadratic equations. So, our objective for today is to solve problems by translating to quadratic equations. So what we're going to see today are some word problems, and we are going to utilize our quadratic equations to solve for missing values in a real life context. So let's start with this first one here. I'll read it for you guys. A picture frame measures 12 centimeters by 20 centimeters. 84 centimeters squared of picture shows inside the frame. Find the width of the frame. So whenever we're approaching these word problems, it's best to always use the information we're given and try to make sense of that and use a picture. So luckily we have a picture here. We have a picture of a picture frame. And there's somebody inside waving at you. Okay, so it says the picture frame measures 12 centimeters by 20 centimeters. So I'm going to label the sides. So the length is 20 centimeters, the width is 12. And we also know that the inside of the frame here is 84 centimeters squared. So that's area. And we know we get area from length times width. Right? And we're looking for the width of the frame. So this width here is what we're looking for. Alright, before we get started, let's do some other things. So I'm just going to draw a box here, and I'm going to choose the variable x. So the width, which is really what we're solving for, x, we're saying is this right here. We have x. And I could do this to all four corners. And I know that each line, the screen line I'm drawing in right now, is x. Okay, what's some other information that we already know? Well, I could tell what this length is here. So if I'm told that this whole side is 20, and we would subtract this length of x and this length of x, we would get here 20 minus 2x. Okay? So the same thing's going to follow for this width of the inside of the picture frame. So I have 12, covers the whole thing, minus this x here and this x. So I get 12 minus 2x for this width here. Now, let's use some more information we already know. Let's get rid of that. Okay, so we're given that the area of the inside of the square, I'm just going to put the area of the square here, is 84 centimeters squared. We also know that the area of the squared is just its length times width, and we just found what those are. 20 minus 2x times 12 minus 2x. And now we can multiply and double distribute, or FOIL, you may know it as. So we know that the area of the square is 84 centimeters squared. So I'm just going to go ahead and plug that in here. And now I'm just going to double distribute. So I have 20 times 12, I get 240. Okay, 20 times 2, or minus 2x. So I have 40x. Next one here, minus 24x. And plus 4x squared. Okay? So next thing I'm going to do is I'm going to move this constant term over to the right hand side and set this equal to 0. So here I'm going to have 4x squared, and I'm going to combine these like terms. So I have a negative 64x, and when I subtract both sides by 84, I get plus 156. So now this is what we've been doing, is factoring, and we can take out a GCF, which we have 4 here, so I'm going to rewrite this as 0 equals x squared minus 16x plus 39. And then my next step, I'm going to draw these parentheses here and fill in the blanks. So we get x minus 13 and x minus 3. And we can solve each of these for 0. So I have x minus 13 equals 0. And I also have x minus 3 equals 0. And to solve for x, I get x equals 13 and x equals 3. So I solved and got two values for x, but we only can use one. And let's think back in the context of this problem. Does it make sense that this length of x could equal 13? The answer would be no, because this whole side here is just 12. So it makes more sense that x could equal 3 here. So we will use x equals 3 centimeters. Don't forget that unit. X equals 3 centimeters to solve for the width of the frame. Okay, moving on. Another problem. An open box is to be made from a 10 centimeter by 20 centimeter rectangular piece of cardboard by cutting a square from each corner. So we already had these squares drawn in. The area of the bottom of the box is 96 centimeters squared. Notice that's area. What is the length of the sides of the squares that are cut from the corners? Okay, so let's kind of draw this out like we did in the last problem. So I'm going to draw in that bottom of the box, which we were given that the area of the bottom of the box is 96 centimeters squared. Okay. We're also given that the box is made from a 10 centimeters by 20 centimeters rectangular piece of cardboard. So I'm going to label these sides 20 centimeters and I have 10 centimeters here. Okay. So similarly to what we did last time, I'm just going to use the variable x here. And the problem said that we have squares from each corner. So that's how we know that these are the same, that it's x and x on both sides. Okay, since we have the area of this inside part, let's try to find the length and the width that border this. So if we have 20 here for the width of the big cardboard box, and we would subtract this x here on the right side by another x on the left side, we would get 20 minus 2x. Very similar to what we did in the first example problem. Then we're looking for this width of the inside box. So now I'm going to take the length, the width, which is 10 centimeters, and I'm going to subtract these boxes on the sides. So just like we did before, we have 10 minus 2x. Alright. So using what we know that the area of that inside box is 96 centimeters squared. And we know that area is just length times width. So we have 20 minus 2x. And we'll multiply that by 10 minus 2x. Okay, so we could go ahead and calculate this out by double distributing or foiling. So I'm going to give you guys about a minute to do that on your own and come back and we'll check our answers with each other. Okay, put me on pause. Okay, so you guys can see here that I double distributed or foiled this problem out. I went through all my steps here. I divided both sides by 4. And I got two factors of x minus 13 and x minus 2. And my final answer is x minus 2 centimeters. Okay, don't forget that label there. Okay, we are going to look at a problem involving a triangle. So remember our Pythagorean theorem. We have a squared plus b squared equals c squared. So we will use this in our next problem. So the problem asks, a ladder is 2 feet longer than the height of a certain wall. When the top of the ladder is placed against the top of the wall, the distance from the base of the ladder to the wall is exactly equal to the height of the wall. How high is the wall? So let's try to use what's given to us. A ladder is 2 feet longer than the height of a certain wall. So let's give this the height of the wall x, and we're told that the height of the ladder, which is this slanted, that's our ladder, is 2 feet longer. So we're going to represent that as x plus 2. So it says that when the top of the ladder is placed against the top of the wall, the distance from the base of the ladder, right here at this point, to the wall is exactly equal to the height of the wall. So that would mean it's x. So clearly this triangle is not to size. So it asks how high is the wall. So we're solving for x here. So we know that what we just said before, a squared plus b squared equals c squared. So we can write this as x squared plus x squared equals, then our third side, x plus 2 squared. Okay, take a couple minutes, use your properties that we've been using, and let's multiply this out and solve for x. So put me on pause. We'll meet back in a couple minutes. Okay, so you can see here the steps that I took to solve for x. So what I started with is I did FOIL here, I double distributed, and I got x squared plus 4x plus 4 on the right side. And on the left side, I just combined my like terms to get 2x squared. And then I put it all to one side, set that equal to 0. And as you can see here, I used the quadratic formula to solve for x because I couldn't think of a perfect factor just off the top of my head. So I solved this down and I got 2 plus or minus 2 square root of 2. So I took them individually. I had x equals 2 minus 2 square root of 2, and I got a negative decimal. And obviously my x is not going to be a negative length, so I could rule that option out. Instead I looked at my x equals 2 plus 2 square root of 2, and I got, that's about 4.828. And I said that was my final answer. And last thing that I need to include to make this complete is to add my units. Okay, so that concludes lesson 8.2 today. Come in tomorrow with any questions you may have on these word problems. We will see many similar problems like this. So, good job today. Keep working hard and we'll get through this together. Good job. We'll see you tomorrow.